Hello, and welcome to Module 10.7, Factoring Special Products. Our objective for today, first, I can factor binomials that are the differences of squares, and second, I can factor trinomials that are perfect squares. So our two vocabulary terms for the day, difference of two squares, this is going to be the product of a sum and difference of two quantities. And so we are going to see that first. Then we're going to follow that up with perfect square trinomials. They are squares of binomials such as the quantity a plus b squared and the quantity a minus b squared. So let's look at the factoring of the differences of squares. We've got a squared minus b squared, and what that's going to end up equaling is a plus b times a minus b, or a minus b times a plus b, right? Because those are obviously, we can rewrite those based on the associative property of multiplication. So we've got x squared minus 9. So what we're looking for is we are looking for two terms that are both perfect squares. And if they're both perfect squares, we can write what are the perfect squares. We've got the first term is x squared, and our second term is 3 squared, right? X squared minus 3 squared. That's what x squared minus 9 is. So then we just rewrite it as x plus 3, x minus 3. Difference of two squares is literally that easy. So our second example, we have 16x squared minus 25, right? Our first term is a squared term, perfect square. Our second term is a perfect square, and it's the difference we are subtracting. So 16x squared is going to be 4x to the second power. 25 is going to be 5 to the second power. So when we rewrite that, we have 4x plus 5, 4x minus 5. All right, so let's look at example 1, factor the difference of squares. What to look for? We're looking for two terms that are both perfect squares, and one term is subtracted from the other. So when we look at this, x squared minus 100, those are both perfect terms, perfect squares. So we have an x that's being squared, and 100 is just 10 squared. So when we rewrite this, we have x plus 10, x minus 10. Okay, x plus 10, x minus 10. Now, I know you don't believe me, so let's check our work on this one. So x times x is x squared. X times negative 10 minus 10x. X times positive 10 plus 10x. Negative 10 times 10 is minus 100. Hey, look, x squared minus 100. It's the difference of perfect squares, right? So if you're thinking back to lesson 10.4, where we did special products, that was a way for us to be able to identify and see these special products that we can make factoring a little bit easier and a little bit faster on ourselves. All right, letter B. We've got 4x squared minus 49. So 4x squared is 2x, the quantity squared. 49 is 7, the quantity squared. And so now we just rewrite it as 2x plus 7, 2x minus 7. Now, does it matter which one goes first? No, it doesn't. I have a tendency to write the positive one first and the negative one second. There's no right answer to it. If you wrote 2x minus 7 times 2x plus 7, that is appropriately written as well. All right, letters C and D are you tries. Go ahead and do them on your own now. All right, so letter C, we've got 64 minus x squared. So 64, well, that's a perfect square of 8 squared. And minus x squared, that's x to the power of 2. And now we rewrite it as 8 minus x, 8 plus x. There you go. I did it backwards this time. 8 minus x, 8 plus x. Okay. And letter D, we've got 81x to the 4th. So we're looking for what's the square root of that. So 81, square root of 81 is 9. X to the fourth square root is x squared, and we're squaring that, and then minus y squared. So when we rewrite it, you have 9x plus y, and you have 9x minus y. And when you FOIL that, 9x squared plus y, and 9x squared minus y, right? And when if you were to FOIL that, you get 81x to the fourth minus 9x squared y plus 9x squared y, and then minus y squared. And those middle terms cancel out. And you're left with 81x to the fourth minus y. All right, let's take a look at the next page. We're going to factor more than once for this one. So let's take a look at letter A. We've got x to the fourth minus 256. So I know x to the fourth is x squared being squared minus, well, 256, that's 16 squared. So when I rewrite that, I have x plus 16, x squared plus 16, and x squared minus 16. But wait, that's where this double factoring comes in, because I still have a difference of two squares. So my x squared plus 16 remains the same. And then actually we're not even going to write that in right now. We're just going to leave that. We'll bring it down in a moment. So now we've got x being squared, and we have minus 4 being squared. So you have x squared plus 16, right? We're bringing that down from above. And then we have x minus 4, x plus 4. So you're going to need all three terms for that one to be correct. All right, let's look at letter B. X to the fourth minus 81. Well, x to the fourth, well, that's x squared minus 9 squared. So we have x squared plus 9, x squared minus 9. But hey, wait a minute, that's difference of two squares again. So we have x plus 9, not 9, x plus 3, x minus 3. And you still have your x squared plus 9 out in the front. Okay, letters C and D on your own, go. Letter C, we have 16x to the 8th. So when we rewrite that, that's 4x to the 4th being squared minus y squared being squared. So you have 4x to the 4th plus y squared, and you have 4x to the 4th minus y squared. But that's the difference of perfect squares again. And so you have 2x squared plus y, 2x squared minus y, and we bring down the 4x to the 4th plus y squared. So you have three terms there. All right, letter D. We are going to start off 625. Well, that's 25 squared minus w squared. And when I do that, I get 25 plus w squared and 25 minus w squared. But that's still difference of perfect squares. And so now I've got 5 plus w, 5 minus w. And we bring down the 25 plus w squared from the previous term. All right, so now example number 3 is going to be using factors to find area. So Rosita's family is buying carpet for their living room, which is 6 meters wide and 6 meters long, so it's a square. They plan to carpet the whole area except for a square near the door, which will be tiled. Find the factors representing the area of the living room that will be carpeted. All right, so we know that the area of the whole thing is 36, and we're taking away the area of the small inset by the door, x squared. That is the difference of two squares. So you have 6 squared minus x squared. And I put my parentheses on the wrong side of it. There's the x. And that is going to give me 6 minus x, 6 plus x as my two factors. Letter B, Graciela is crocheting a square that will be used to make a blanket. The center square is 6 inches wide. She plans to use blue yarn to create a border that makes the square X inches wide. Find the factors that represent the area created by the blue yarn. All right, so we want to find the area created by the blue yarn. So that's going to be the total minus the colored part. So the total area is x by x, or x squared, minus the inner area that's going to be colored, which is going to be 36. So when we factor that, we've got x minus 6 and x plus 6 as my two factors. Now, you've got letter C on your own. A rectangular solid has a volume of x to the fourth minus 16. Factor the polynomial to determine the dimensions of the rectangular solid. So we start off with, we've got x to the fourth minus 16. Well, that's x squared minus 4 squared. So you've got x squared plus 4. You've got x squared minus 4. Difference of two squares. So you've got x plus 2, x minus 2, and you have the x squared plus 4. So those are your three dimensions of that solid. 1, 2, 3. Length times width times height will give you the volume of a rectangular solid. All right, so we're going to go ahead and take a look at our last page of these notes for today. We've got factoring perfect square trinomials. So in this case, if you have a squared plus 2ab plus b squared, your trinomial is going to be the quantity a plus b squared. And if you have a squared minus 2ab plus b squared, it's going to equal to a minus b, the quantity squared. So let's take a look at our values. Our a value in the a term is x. Our b term is 5, right? Because we took the square root of those two. So we've got 2ab. So it's 2 times x times 5. Well, that equals 10x. So we have the quantity x plus 5. So what we're looking for is we're looking for the first term and the last term are perfect squares. And the middle term is twice those two factors multiplied together. So if we look at letter A and B, the square root of 4x squared is going to be 2x. The square root of 49 is 7. 2 times 2x times 7 is going to give me, well, 2 times 2 is 4, times 7 is 28. And this is going to be a negative 7 because we have negative 28. So it's going to be negative 28, which is what we originally had. So we know this is 2x, and it's going to be minus 7. So what are we looking for? First and last terms are perfect squares, and our middle term is twice the product of one factor from the first term and the factor from the last term. So x squared plus 6x plus 9. When we look at that, first term, perfect square. Second term, perfect square. X and 3 is the middle term. 2 times those values. 2 times 3 is 6, times x is 6x. So it's x to the x plus 3 squared, Or if you want to write it as x plus 3, I would accept that as well. Letter B, we take a square root of our, well, let's look at it. 9x squared plus 24x plus 16. First term, last term, both perfect squares. So let's see if we can take the square root. 9x squared, square root is 3x. And 16 square root is 4. So 3x plus 4, let's see if that middle term works. 3 times 4 is 12, times 2 is 24, times x is 24x. So then we've got 3x plus 4 there. All right, letters C, D, and E are you try problems. Do them on your own. Go. All right, x squared minus 14x plus 49. Two perfect squares, double of the square roots in my middle term. So square root of x squared is x, square root of 49 is 7, and our bossy b term is negative, so it's subtracting. And we do x minus 7 again. Letter D, first term is a perfect square. Last term is a perfect square. So we take the square root of them. We've got 4c and we've got 9. Bossy b term is negative, so we are subtracting 4c minus 9, the quantity squared. Last one, you're building a square patio. The area of the patio is 49x squared minus 42x plus 9. And I want to know what is the length of one side of the patio. So we're going to factor that. 49x squared factored is 7x. 9 factored is 3. My b value is negative and is bossy, so it's going to be 7x minus 3, the quantity squared. And that's the end of our notes for today. If you have any questions, please bring them to class tomorrow. Otherwise, I hope you have a great day.